All right, so again, we just talked about a contradiction, and this is a contradiction. And when we have a contradiction, we have no solution. And our solution set is the empty or the null set. Okay, this is called the empty or null set. So now we talked about the three types of equations. We've talked about the difference between an equation and an expression. Now let's talk about a solution. And we're going to see how to check solutions. So if I ask you if something's a solution, you'll plug it in and you'll see if the sides are the same. So let's just look at an example of a question where I'm going to give you an equation and I'm going to say is, let's say x equals 5, a solution to 4x plus 3 equals 9. So I want to see if x equals 5 is a solution. Now, what does it mean if something's a solution? Well, it means if I plug that value in, then the sides are going to be the same. So let's go ahead and check. And we're going to plug in x equals 5. So that's going to be 4 times 5 plus 3 equals 9. Okay, 5 times 4 is 20. Plus 3 makes it 23. And does 23 equal 9? No. Okay, this is false. So x equals 5 is not a solution. And so there are several questions in your homework where they want you to see if this variable is a solution or not. And how do we do that? We plug it in and we see if the sides match up. Now let's work with equations. So we're going to solve some equations here. Then we'll take a break, we'll come back, and we'll finish up this section. So let's now go ahead and focus on solving some more equations. And now let's look at some that have fractions. So we're going to learn how to solve these and review them. And when we have fractions, we want to clear out the fractions. And there's different techniques based upon what type of fraction we have and how they're set up. So if I gave you this equation to solve, this has fractions in it, and we notice that both sides contain fractions, right? And it's a fraction equaling another fraction. And everything on the left is under one fraction bar, and everything on the right is under another fraction bar. So the technique that we can use to solve this equation is we can cross multiply. When you have a fraction equaling another fraction, you can use the technique of cross multiplication. So we can go ahead and cross multiply here, and we have 4 times 5x plus 4. We put the 4 in front. And the other side, when we cross multiply, is 9 times 3x plus 2. We can solve this out by distributing through that 4 and distributing through that 9. And so that gives me then 5 times 4 is 20x. 4 times 4 is 16. 9 times 3 is 27x. And 9 times 2 is 18. Now we know what to do. Parentheses are gone. We need to move things around. So the variables are on the left. So we're going to move that 27x over. That leaves you then with minus 7x plus 16 equals 18. We'll move that 16 over. And now we've got a minus 7x equals, now watch your signs and be careful, looks like a positive 2. Divide by your negative 7. And when you rewrite this, bring that negative up to the top. And now we have x equals a minus 2 sevenths. And we talked about the 3 types of equations. So what type of equation is this? Well, this is called conditional. So this is called a conditional equation. Why is it conditional? Because we have an answer. Now let's move on and look at some more fractions. So that's one type when a fraction equals another fraction. What happens if we have whole numbers and fractions all mixed together? Well, if we have that, then we're going to have to clear the fractions. So let's look at this one. How would we solve this one? This is the type of question that students are going to struggle with more than any other. When we solve equations, we generally don't have trouble with any equations except for this type, the ones that have fractions. And we're going to focus on a lot of these. So if I give you this, it looks intimidating because we're just not used to working with fractions. We are going to get rid of those fractions as quickly as we possibly can. Now, what we do is we look at our denominators. So what are our denominators? We have a 9, 3, and a 4. So I'm going to take the denominators, and I'm going to do them in pairs together. So let's try to take the least common denominator of 9 and 3. Okay, the least common denominator of 9 and 3, that's going to be 9, right? Because 9 goes into 9 itself 1 time, and 9 goes into 3 3 times. So the least common denominator of 9 and 3 would be 9. Now we take that 9 that we just found from the first two, and we take it with the 4. And what's the least common denominator of 9 and 4? Well, 9 and 4 have nothing in common. And 9 times 4 is a 36. Okay? So that's our magic number. So what we're now going to do is we're going to multiply every piece by 36. Because when I multiply every piece by a 36, that is going to remove all of our fractions. So let's go ahead now and multiply everything by 36. So we're going to start with our first fraction. When we clear these fractions out, what we do is we divide by the number down below in the denominator. We multiply then by the number on the top in the numerator. So divide by the number below, multiply by the number on top. So 36 divided by 9. Well, 36 divided by 9 is 4, right? Okay, and 4 times the 4 in the numerator makes it a 16, and we'll bring the x down. So 36 divided by 9 is 4. 4 times 4 makes it 16. And we'll bring down our negative for our next piece. And 36 divided by 3. Well, 36 divided by 3, if you need to, you can always use a calculator. Don't ever feel like you can't. So 36 divided by 3, that's going to give you what? It's going to give you 12, right? Okay, so 36 divided by 3 is 12. 12 times 1 makes it a 12. And don't forget to bring your negative down. Now we repeat with the next one. 36 divided by 4. Well, you can either know that that's 9 or you can use your calculator. Okay, 36 divided by 4, that gives you what? 9. Okay, and then what do? We multiply that 9 by what? The 3. And that gives you then 27. And bring down your x. And the very last piece, what do we have that's left over here? Well, there's no fraction, so we just take 36 times 8. And that leaves you then with 288, doesn't it? Now we've got something that we can work with. We now can move things around, use a calculator, make sure you don't make a mistake. So let's start with our x's. So let's move that 27x over. And again, don't ever feel like you can't use a calculator. I would rather you use a calculator than make a mistake. The last thing you want to do is make a simple mistake and get really frustrated because you added or subtracted incorrectly. So what do we have? We have 16 minus 27. What does that leave you with? It leaves you with a minus 11x. And we know it's negative, by the way, because these are different, so they're going to subtract. And which one's larger? 27. And what's the sign of the larger number? Negative. So that's going to make that then a negative 11x there. Okay. What about the 12? It just comes down as a minus 12. The other side, those cancel. That left you with a 288. We're now going to add our 12 to both sides. I'm going to try to make this one pretty easy to work with. So that gives you then a minus 11x. We've got 288. We're going to add 12 to that, and that gives you then an even 300, doesn't it? Divide by a negative 11. 11's a prime number, so it's not going to reduce. So then what's my final answer? Bring the negative up to the top. Minus 300 over 1. 11. Okay, and that's your final answer. And this, again, is an example of a conditional equation. So that's an example of a conditional equation. Let's go ahead and take a short break. I don't like us to be sitting down for more than about 45 minutes to an hour. We'll take a short break. We're going to come back. We're going to finish up this section and then start the next one. So let's take about a 15-minute break. And let's meet back here at 9:40. That'll give you plenty of time to get up, walk around. So find something to eat and drink if you need to. But we'll start back at 9:40.